Hello, this is William from Visual Components. In this video, I'm going to show you how to teach a robot a while statement. Now, a while statement allows you to execute a loop in a robot program. How it works is you define a condition. If that condition is true, the robot will execute a scope of statements. The robot will then loop back, re-evaluate that condition, and if the condition is true, the robot will repeat that same scope of statements, over and over again until the condition is false. If the condition is false, the robot will not execute the scope of statements. So it's very similar to a while statement in programming languages. To give you an example, add any robot you want to the 3D world, go to the Program tab, and in the Program Editor panel, I'm working with the main routine. I'll now click this icon here to add a while statement, and notice a while statement is listed with its condition, and it has one scope of statements. So as long as this condition is true, any statement in this scope will be executed. Let's now add some statements here to see how this works. So let's actually move the robot all the way down here and add a point-to-point motion statement. And then let's move the robot all the way up and make that another point-to-point motion statement. So here is the scope of our while loop, and right now its condition is true. So if I reset the simulation and run it, notice the robot is kind of going up and down, over and over again. Because the condition of our while loop is still true, so the robot knows it can still execute that scope of statements over and over again. Let's reset. And now if you want to edit the condition of a while statement, just select it here in the Program Editor panel. Go to the Statement Properties panel, and notice here is its condition property. Now this allows you to define an expression, and when that expression is evaluated, if it returns a true value, the robot knows to execute the scope of statements. If the expression returns a false value, it knows not to execute that scope of statements and exit out of the loop. So you can write a true value here or a false value. You can also pass a 0 to be a false value, or any number greater than 0 will be a true value, so 100 will be true. You can also use arithmetic, so you can say 2 plus 2 is equal to 4. We know that that will return a true value. You can also use conditional operators, so you can use ampersands here to equal an AND. So I can say 3 plus 3 is equal to 7. Now notice here this statement is false, but this is true, but we're using an AND here. So both of these have to be true in order for the whole condition to be true. Likewise, we can use an OR operator, so that's with two pipes. So if either of these statements is true, then this whole condition will be true. You can also use the properties of a robot for your condition. So if I select the robot in the 3D world, these default properties you can see here, you can reference them by name. So, here are the joints of the robot J1 through J6. So in my condition, I can just type in here J1 is equal to 90 degrees. And if J1 is equal to 90 degrees, if that's true, then the loop will execute the scope of statements. But if it's false, the robot won't do that scope. Now, if you want to reference the properties in these tabs here, it's very simple. Just reference the tab name followed by 2 colons and the property name. So here I'm in the Executor tab, and I want to reference this isEnable property here. I can go back to my while statement, and I can say Executor, colon, followed by that property name, and I'll say if it's equal to true, then execute that scope of statements. But if this property value is false, it will exit out of the loop. Now another way to write an expression is to use a variable in a robot's routine. Now, as long as the variable is in the same routine as your while statement, you can reference it here in your condition. So if I go back to the Program Editor panel, select the main routine. In the Routine Properties panel, I can create a new variable that's an integer called count, and right now it's at 0. So in our Program Editor panel, let's create an assign variable statement. And let's first make the count variable equal to 0, and then in our while loop, what we'll do here is we'll increment the value of our count variable. So I'm actually going to add it to my while scope here. Just drag it on top of the while statement, and you can see it's now nested here. Let's now set the target property to be count, and reference the current value, and increment it by 1. So every time this scope of statements is executed, the count variable is going to increase by 1. So for our while statement here, let's set its condition to be that as long as the count variable is less than 5, return a true value, and execute these scope of statements. And let's see how that works. So let's actually select our main routine here so we can see the count variable's current value. Run the simulation. So right now it's 1, 2, 3, 4, and eventually it reaches 5, and we exit out of this loop here. Let's reset. Now if you need any more help with writing an expression, you can go to the help file by clicking this button here, expand the reference guide, expand expressions, and these topics can help you write your functions and other things for your expression. Now before I end the video, I want to quickly show you how to teach a robot break, continue, and return statements, because you will often use these statements in a while loop. To get started, in the 3D world I have a layout open, which you can find a link to in the video description. So open that layout, and what I did, I programmed this robot to pick parts from these conveyors and place them over here. If I go to the Show group and select the Signals checkbox, you can see I wired sensor boolean signals to the input ports of this robot at input port of 100 and 101. Now whenever you're writing an expression for the condition of an if statement or a while statement, you can reference these input ports of the robot. For example, in the program editor panel, you can see I have a very simple condition for my while loop, and I have two if statements. So if input port of 100 is true, the robot will pick and place a green part. If the input port of 101 is true, the robot will pick and place a pink part. Now let's go ahead and simplify this for our while loop. So I will delete the if statements. I'll then add a wait for binary input statement of 100. And we'll wait for it to have an input value of true. And let's actually make that before our delay. Let's then add two calls to subroutines. So our first call will be to pick a green part, and our second call will be to place that part. Let's now add a comment statement just for space, and now let's add another wait for binary input statement for input port of 101 to be true. We'll then add two call subroutines. So the first call will be to pick a pink part, and the second call will be to place that part. So now we have a very simplified while loop. If I run the simulation, we should see the robot pick and place green parts and pink parts. And it does. And notice this loop, it just goes around and around. The robot just goes in this order. It picks the green part, then the pink part, the green part, then the pink part. Let's reset. Now sometimes when you have a while loop, you want to exit out of the loop before evaluating its condition. So notice here I have a very simple condition. But what we can do, after we pick and place a green part, let's break out of this loop. And we can do that by adding a break statement. And then after a while loop, let's print a message. So I'll add a print statement, and I'll just make it print exited out of while loop. There we go. So if I run the simulation, the robot should pick and place one green part, and then it's done. And yep, notice the robot's not doing anything, but it did print out exited out of while loop, so it did this statement of our while statement, and then it printed out this message, and now the robot has nothing to do. Let's reset. And instead of breaking out of this loop, let's use a continue statement. So what that continue statement will do is that it will do these first three statements, and then with the continue statement, let's actually add it now, it's going to skip over the rest of the statements in the loop. So it'll do all these statements, but skip these, go back around, evaluate the condition, and execute the loop. It will then continue, skip them, and just keep on going back and forth. So now what the robot should do is just pick green parts. And there it goes. Yep, it's completely ignoring these pink parts. Let's reset. And now let's see how a return statement works. So I'll go back to my main routine, delete this continue statement, and let's say after we pick and place a green part we want to return. So what will that do? Let's run the simulation and find out. So the robot will pick and place a green part, and now the robot has nothing to do. And you can see that it also did not print out an additional message that it exited out of the while loop. That's because a return statement, yes, it can act like a break statement, but it's returning to the routine that called this subroutine here. So since we're working with the main routine, this return statement kind of ended the whole robot program. But if we reset, delete this return statement, but now call it in our place part routine here, let's see what happens. So we'll add it to the end of this subroutine. And what's happening here is that whatever routine called this subroutine here, it's going to return back to that caller, which in this case is our main routine. So let's run the simulation. The robot picks the green part, places it, and returns back to do just that. And there you go. Let's reset. But now let's see how this return statement works when you're having a while loop in a subroutine. So let's go to our main routine here. And instead of doing all this, let's delete our 3 statements here. Let's add a new sequence and call it pick place green part. And what we'll do, we'll call a subroutine to pick a green part, and then we'll add another call to place the part. And let's actually use a variable here. So let's say we only want to pick and place 5 green parts and then return back to the main routine. So let's actually select our new sequence here, pick place green part, add an integer variable, and call it count. And at the start of the subroutine, let's set the count variable to be equal to 0. Let's now add a while statement. Oh, getting crazy. And let's now drag these call statements into our while statement. But let's actually add a wait for binary input statement to the start. So we are waiting for a part to be picked. So let's say input port 100 is equal to true. And let's change the order here so that we wait for a part to reach the sensor. We then pick the green part, place it, and loop back around. But after each iteration of this loop, after we finish the scope, let's increment the value of our count variable. Count equals count plus 1. Now what we could do, we could write a condition here saying if count is less than 5, exit out of this whole loop and the whole subroutine will be finished. But now let's add an if statement. So if input port 101 is equal to true, then let's return. Let's go back to our main routine, and in our while statement here, let's add a call and make that the first statement in this sequence, in this scope, and then we'll call that pick place green part. And then will the program eventually get to here? Let's find out. So let's run the simulation. So far so good. Robot is picking and placing those green parts, but it does not seem like it's actually getting back to these pink parts. So what we need to do is reset. And I think what's happening here is that we did not delete that return statement in our place part subroutine. So let's delete it here. And now let's see how this works. So in our main routine, we'll call this sequence here to pick and place the green part. And in that call, we'll have a while loop here. It's going to pick and place a green part, increment this variable, and if we notice that that input port of 101 is true, the robot knows to go back to our main routine, or whatever routine called it, and then continue on. So let's run the simulation. Robot picks a green part, and haha, it fixed it. So now the robot is picking and placing green parts and pink parts. Alright, this concludes the video. If you have any more questions, please feel free to visit our forum at forum.visualcomponents.com. And as always, have a wonderful day.